This 33 Mauritian time, we will make a start. Before starting the event, I would like to notify that this session will be recorded for improvement of future events. So, greetings everyone, honorable members of the jury, respected officers, competitors, and dear audience. Welcome to the Speak Out for Engineering, Middle East and Africa Regional Heats 2022. My name is Deepshika Bukal. I am a mechatronics engineering student currently doing my level 3 at the University of Mauritius and an affiliate member of IMechE and an executive member of IMechE Students Chapter of the University of Mauritius. I will be your host for today for the first half of the event, along with Suleiman Ahmed. Hello, Suleiman. Suleiman, are you here? Suleiman? Okay, maybe he's having some technical issues. Okay, so Suleiman is a student of mechanical engineering, third year mechanical engineering student, rather, at the National University of Sciences and Technology in Pakistan. He is the public relations officer for the IMechE Students Chapter at his university, and he will be with you for the second half of the event. So Sophie is an annual presentation competition organized by the Institution of Mechanical Engineers for young aspiring engineers with the aim of promoting interest in the art of communication. It is designed to help develop verbal and visual communication in explaining technical, mechanical engineering related subjects. Good communication, presentation skills, creativity, and intelligence, important tools for engineers without which so many innovative ideas and projects would never have reached the world. After all, the art of communication is a language of leadership. Wise words of Mr. James Hume, the famous author. And this is why Sophie assesses the competitors mainly on their communication skills and less on technical content. 90% of total marks are allocated to presentation skills and only 10% for technical content. Speak Out for Engineering competition heats takes place across the globe, and winners from each heat are invited to participate in their regional final, and the winners of the regional finals are invited to participate in the annual global final, winner of which will be crowned the overall Sophie winner. So before we begin, I would like to invite the judges to introduce themselves and say a few words. Can we start with Mrs. Lolita Wickramaratchi from Sri Lanka? Is she here? Mrs. Lolita, are you here? Okay, if she's not here yet, we will proceed with the second judge of today, Mr. Sarfaraz Nazir from Texas, the US. Can we have you, sir, please?
Yes, thank you. This is Sarfaraz Nazir. My educational and professional background is industrial engineering. I am a distinguished Toastmaster and 3-time world champion of public speaking semi-finalist where I took second place twice. I am a co-author of Go Ahead and Laugh, a serious guide to using humor in speeches. Back to you, Madam Hostess.
All right, thank you, sir. Now we will proceed with Mr. John Pollard from Merseyside and North Wales. Mr. John.
Hello, everybody. My name is John Pollard. I live in Chester, which is in the northwest of England. I spent my entire working career, 35 years, with Unilever. If you haven't already used a Unilever product today, you probably will do before you go to bed. So fast-moving consumer goods in a variety of engineering, operational, and managerial roles. I retired about three and a half years ago, and I live the happy life of a retired person.
All right, thank you, sir. We will have our next judge for today, Mr. Peter Brewer from the UK.
Hello, and thank you for inviting me. I'm Peter Brewer. I work in developing offshore wind farms. I am a member of the IMechE, and I also have worked in the electricity supply industry for about 35 years. All of that has been in the operations phases. And thank you for inviting me.
Thank you, sir. We will now have our next judge of today, Mr. Mohammed Qayyum from New Orleans. Sir.
Thank you. Good day, everyone. My name is Mohammed Qayyum. I am in New Orleans, Louisiana, USA. I work in the cybersecurity field, and I am a member of Toastmasters International, which is a communication and leadership building organization. Back to you.
All right, thank you, sir. We also have among us today some special guests, Mr. Hassan Ansari, Chartered Engineer and IMechE Fellow, Mr. Gohar Shukat, Young Member of Panel Chair of IMechE Pakistan, Dr. Muhammad Unib, the Contest Chair from IMechE Pakistan, and Mr. Faisal Said, the Vice Chair of IMechE UAE Panel. Thank you everyone for your introduction. Now we will move to the rules of the competition. Some rules that we must keep in mind during the competition. Each participant will be allocated 30 minutes in total. The first 20 minutes will be for their presentation, and the remaining 10 minutes will be for the question and answer session with a jury panel. Our technical team will play the pre-recorded presentation videos, and then we will proceed to the live question and answer sessions with the judges. Once the presentations are over, Dr. Unib will facilitate the questions and answer session to the participants. In the meantime, if the audience has any questions for the participant related to their topic of presentation, they may send them in the chat box. I will direct them to the competitor, provided that the allocated 10 minutes of Q&A are not over. However, if the respective competitor is not present for the questions and answer session, they will be disqualified. Throughout the event, everyone's mic and camera will be disabled unless you have to speak. This is to ensure that there is no background noise or disturbance during presentations or during interaction of the judges and the competitors. Now we'll move to the agenda of the event today. The competition will proceed as follows. There will be the presentation and the Q&A session for the first three competitors, Ms. Subiksha Sugumar, Mr. Krishnadev Pentaya, and Ms. Nurey Mamadzada, followed by a short break of about 15 minutes, and then the event will resume with a resuming event speech the presentation of the remaining three participants, Mr. Norman Afzal, Mr. Samson Ojim, and Mr. Brian Dobra. And after the presentations, there will be another break where the judges will be discussing about the winners, and our winner today will be announced for the closing note. If you have any questions, please do not hesitate to send us on the chat box. With that said, I would like to wish all the best to all the competitors today, and on this note, we will make a start. This is Speak Out for Engineering by IMechE, improving the world through engineering. So our first competitor today is a lady. She is Miss Subiksha Sugumar, a final year mechanical engineering student of Manipal Academy of Higher Education in Dubai, and she is from United Arab Emirates. She will be presenting her internship project, design of low-cost, high-mobility prosthetic arm.
Greetings to everybody present. Hope you all are doing well during this pandemic period. A warm welcome to all the judges and all the best to all the participants taking part today. I'm Subiksha from Manipal University Dubai campus, and it's a great honor for me to take part in this IMechE Sophie 2021. To start with, everybody have so many life experiences, so many beautiful memories created by them, and some of them are because of challenging experiences as well, which might be from the wounds and scars they have come across. And one such challenge is what I'm going to share with everybody today. This person is very motivating, very supportive towards me. She's my grandmother. She was having a beautiful life until one day she was being diagnosed by diabetes. And because of this diabetes, she had a lot of things that she has to come under control, like the food, fitnesses and all. But this was not coming under control. And it went to a particular severe case where the doctors decided that there was no other solution other than going for amputation process. Yes, amputation process. And they had to remove her below the knee part of her leg, and then a couple of her fingers, as you can see in this picture, which really surprised me. Like, how is she ever going to face now? Like, everything is going to be upside down. She has to completely depend on either wheelchair or some people around her. But she took it up as a challenge. And that's when the word amputation, wherever I go and see, it used to attract me, like it used to grab my attention. And these were some of the cases that really blew my mind. How are these people facing these challenges? A person, like an army person who served for the country, for the nation, and then they have lost their arm, but they're very proud about it. A child born without an arm. There are some other professions who really want to get towards their goal, like they have to achieve it. Doesn't matter, like obstacles, like without an arm and all. They just strive towards a goal. These were the ones that really grabbed my attention and motivated me to work on this project. Some other cases that were also surprising was COVID-19 being a part of this. COVID-19 reduces your immunity, and that increases this diabetes and other kind of blood circulation problems. Because of this is one of the amputation case. In US, there's a survey report that says 2 million people have gone through this limb loss, which really surprises me. And then we have another case that says robotic prosthetic market size is expected to grow around 2,000 million by the year of 2028. Talking about the mental health problems, you see, they are completely losing their confidence. Some of them take it up as a challenge, whereas some don't. This completely breaks their inner strength, inner confidence. So because of this, it drives their depression, anxiety, all sorts of stress towards it. And one such problem is PTSD. It's a psychologically found problem, that is post-traumatic stress disorder. This post-traumatic stress disorder is basically the incident keeps repeating again and again in your mind in such a way that this gives you all sorts of anxiety and depression. So, as a solution for this is what we came up with, Ojas. Ojas means inner strength from Sanskrit. Our main vision is going to be three things. One, functionality. Two, the aesthetics. And finally, cost. We're going to balance all these three. Functionality means the degree of freedom, the range of motion. Aesthetics, the way how it looks externally. And cost. Cost is the one that actually decides how it's going to be like. Some people prefer functionality over aesthetics, whereas some prefer aesthetics over functionality. Functionality could be like all the degree of motions are there, but you might have, just like the background picture, a robotic arm, which looks with all those structures. Whereas aesthetics sometimes could be just the silicone one without any functions. But if you want both together, you have to go for such products as is available in developed countries like USA, where a prosthetic arm with a decent price starts from 5,000 USD. And if you want to get a better versions, it goes from $10,000, $15,000, $20,000. But considering a third world country where it's just developing, people from average family definitely can't afford it. 5,000 USD is a huge amount. So they would rather go for accepting or maybe go for a lower cost. The problems that I have identified from low-cost prosthetic arm is, one, the degree of freedom for the wrist mechanism is very less because there's only 1 degree of freedom, whereas in a human arm, we have 2 degrees of freedom. One is rotation, another one is moving back, front, and sideways. Second problem that I identified was the thumb. Thumb plays an important role. As you all know, we can grab or grip anything with the help of this thumb. But if this thumb is not having a good grip strength, a lot of things are not done. So you completely become dependent. And the third problem was that tendon cables. This is having its own pros and cons. It's easy to achieve a mechanism where you can do this close and open, but whereas the long cables that is involved inside has power transmission loss. Because of this power transmission loss, there is some kind of force imbalance, and that might lead to gripping power or gripping strength that could be not as strong as a normal human hand. So these are the 3 identified problems from the low-cost prosthetic arm. To come up with a solution is what we are having here, the Ojas prosthetic arm. Under this, we have 4 categories. We'll be focusing mainly on the mechanical design, electrical components, then we have the design evolution, and finally the manufacturing. From all these things, we can identify what is the improvement from the Ojas prosthetic. To start with, we'll start with the mechanical design. We are mainly focusing from below the elbow. That's why we have wrist and finger mechanism considered in this case. So this is completely based on mechanical design. Finger mechanism is basically, instead of going for a tendon cable, how about we go for a 3-link mechanism? By using a 3-link mechanism, it is easily achieved to get a 3 degree of freedom. So this is how it will be looking like, and this 3 degree of freedom is achieved by actuators that's placed in the bottom. These actuators will help in forward kinematics mechanism. Now you might wonder, there's only 3 fingers. Where is the 4th and 5th finger? Well, to give you equivalent mechanism just like thumb, we're going for this mechanism called shift mechanism. In this shift mechanism, there is a servo motor which is connected to only 1 finger. And this finger has a freedom to move from 0 to 180 degree. And it will easily help you grabbing or gripping anything. For example, holding your laptop or maybe carrying a bag or opening a door can be easily achieved by this. Next is the wrist mechanism. In this wrist mechanism, to replicate exactly like a human arm, after a lot of literature reviews and researches, I've come under conclusion quaternion joint would be the best one. Because in quaternion joint, it is compact and it is completely based on the rolling motion, can easily help us achieve 2 degrees of freedom. That is, rolling at the same time turning around. And this helps us achieve the front, back, and sideways just like a human hand. Coming to the next point, that is the electrical components. We start off with a power source. In power source, this is exactly going to be like a mobile phone where you have to charge it. And for that, we have lithium batteries used in here. It's chemically safe, long lasting, and also it is fast charging concept. Comparing a lead acid battery, this is 60% lower in weight. So we prefer lithium over lead acid batteries. The next one would be the workflow. I've explained to you the finger and wrist mechanism, but how are they going to work? It's by the help of the electrical components. If you see, we have a sensor that senses all the signals from the muzzle, which will be given to this particular microprocessor, and that will give the data to the actuators and the servo motors. So the sensor that is being used is basically EMG sensor, electromyography sensor. This sensor can easily detect the muzzle signals. The muscles always have signals that comes from the brain by the help of the nervous signals. The nervous system is helping us get all these signals to the end of our hands or legs according to our need. So this will basically detect these signals and give it to the microprocessor. So these are a couple of graphs that explains how it has been detected. For example, the first one is the walking motion, running motion, also while eating or writing. This is how it looks like. This is an even more deeper study between the amplitude and the time consumed for each signal. Coming under the microprocessor is basically a chip that will be having a software installed. This can easily take the information from the EMG sensor and give it to the actuators and the servo motors according to the requirement. Next is the actuator and servo motors. I've explained that fingers are using forward kinematics, so that's why we have actuators placed there. And for the servo motor, basically involving an inverse kinematics, which wherever we have the twist, it'll be involved. So one servo motor is placed under the one finger, which gives us the shift mechanism. Another one is placed under the wrist mechanism. That's the reason we have another servo motor there. So that comes to an end for the workflow. And then finally, we'll come to the feedback mechanism. Feedback mechanism is basically, there are a lot of ways nowadays that we could get a feedback mechanism, either by implantation or some other concept. RMIT University from Australia have found a new concept by using the electronic skin. This basically is a particular skin which is made up of electrodes that can be expanded or compressed according to the need. And this particular skin can easily detect any kind of force, temperature, and any sharp objects towards it and can give the signal back to the microprocessor. And it is as light as a feather. So this is one of the advanced technology by giving you the sense of touch. Coming to the design evolution, this is how the design evolution happens. From the finger to the servo motor, then the way how it was in placed to 3 fingers, achieving forward kinematics at the same time inverse, and also choosing a particular wrist joint that is the quaternion joint, and coming to a final rendering view. Coming to the manufacturing side, we have 3 different types. One is additive, DFM, then finally DFA. So the additive manufacturing is basically the 3D printing is what we have chosen for our manufacturing concept. The reason why is it is one of the most essential, and nowadays it's a fast moving method. For example, the mouse which I'm using here is also a 3D printed one. So talking about 3D printing, these are the categories which we have to consider. Design for usability, how it's going to be printed. So we have to design it according to it. Design for slicing, it's not going to be done in a single block. So it's going to be having a fine slicing. Then design for infill. The middle one out there, that is the one which we're choosing. 60% infill for its flexibility. For its design for printability, basically the orientation. Then the design for waterproofing, because there are a lot of electrical components, we would give 0.8 mm as a waterproof. And finally, the material which we choose is ABS. Since ABS is something which is right now, like a lot of market people are using this, we're going for ABS. At the same time, it has a good rigidity and a very good thermal strength. The next one is going to be DFM. DFM is nothing else but design for manufacturing. We will be not printing the entire thing together. So we're going to split it into different parts and print it. So this is basically the structure for the finger mechanism. So all the finger part is being shown here. And this is for the wrist. All the wrist joints, this is how it will be split up and printed. And finally, the DFA, designed for assembly. All the manufactured components has to be assembled together to get the final product. And this is what happens in DFA. So that comes to a conclusion for manufacturing. Let's discuss about the results. ANSYS is a particular software that I used to come under this conclusion. The finger which we have chosen has a capacity of 500 Newton. It can easily lift it. 500 Newton is basically 50 kgs. A finger could easily lift 50 kgs. And that means 3 fingers together can lift up around 150 kgs. It's quite amazing, isn't it? And to see the improvements, the degree of freedom by the before one, the tendon cable, had a lot of problems. But here, if you see, we have given you a 3 degree of freedom. Wrist mechanism has been increased. Power loss has been reduced by removing the tendon cables. And finally, sense of touch, which was not there in the existing one, but now we have created it with the help of an electronic skin. The cost estimation for our particular design is, it only costs around 1,389 dirhams. That is the currency used in UAE. So if you consider it in USD, we can round it up till 400 USD, which is way too economical comparing to the $5,000 ones in USA. Finally, we can come to the conclusion. We have finally promised you with the degree of freedom, and we have increased it, reducing the power loss by the help of the mechanism which we have shown. We have increased the mechanism for the gripping strength by giving you the strength, the shift mechanism, advanced feedback mechanism has been implemented, and finally, additive manufacturing, that is a 3D printing concept, has been used. And towards the future scope of work, a lot more changes, a lot more updates could be done to this design. As you see, fabrication for a commercial purpose, quite different, so we have to design it. Another main pro of the additive manufacturing is that you can design according to a person. So basically, a customized way of finding a prosthetic arm for an individual. And then the monitoring the medical benefits, like for example, heart rate, BP, all these things could also be measured. And finally, integrated speakers and Bluetooth systems could be implemented in future. So thank you. Hope you all liked it. I'm Subiksha Sugumar from Manipal University, and this was my concept, design of low-cost, high-mobility prosthetic arm. Thank you.
Thank you, team. I will now request Subiksha to unmute herself and turn her camera on for the questions and answer session, which Dr. Uni will direct.
By our judge, Peter Brewer. Peter Brewer, would you like to ask a question?
Sorry, Subishka. I have one question for you. You've mentioned how strong the hand is. Could you explain whether you've done any assessment of how strong the attachment to the remaining limb would be?
Yes, sir. So first, greetings to everybody, and it's a great chance for me to take part in the SOFIEL competition. So yes, sir, about the way how it's going to be attached, there are many methods to attach it. Either way, we can drill a hole in the human hand where the attachment is done permanently, whereas here we don't want to do a permanent way. So it's a socket-based concept which we are trying to use here. And that would be easier. So we might have a part of like the body prosthetic where it's partly connected to his other side of the body. It's easier for him to balance the weight of prosthetic arm, which is still not too heavy. It's coming less than 1 kg, but still for his easier use, we are going to make in that process. At the same time, it's going to be a socket method where he can push his other part of the hand inside the prosthetic arm and use it.
Thank you.
Yes, sir.
Okay. The next question from John Pollard.
Hi. What an excellent presentation. You're clearly very passionate about this, which is wonderful to see. How do you see it being commercialized? Do you see this as something that individuals would buy privately? How do you see it? I mean, how do you see the whole commercial side of it?
Sir, this is, as I mentioned it in the earlier part, this is not for some properly developed or advanced technology, but we are mainly focusing on the people who are in need, like the third world countries. And in that case, this will be definitely a commercial way, because additive manufacturing is one of the, like comparing any other manufacturing basis, this is one of the easiest way to manufacture it in a very, what do you say, the limited budget. So we don't have to go for a big process here. And commercial way, if you see, it's easily possible here if we have a good number of 3D printers available, and we can get a proper customized one as well. So this will definitely be a future part of our technology if we have properly implemented that.
Yeah, so you're sort of thinking it could be done in local clinics, that type of thing.
Yes, sir. It will
Excellent.
be easily available, yes. And countries like India, Pakistan, and so many other places can also use this particular concept, because I have seen a lot of videos nowadays, people really like selling these type of prosthetic arms for free for those people especially in poverty range. So in that case, giving them a little more, which is having more functionality like this particular prosthetic arm, will also be more beneficial to them. So it's depending on that particular cost.
Excellent. Very good. Thank you very much.
Thank you, sir.
Thank you. So, Viksha, you mentioned that you used ANSYS software for simulation. What kind of simulations that you carried out, and what kind of sensitivities that you had to take care of?
So the major points which I considered was deformation, because a human is usually like lifting weight and all. So in that case, deformation was my main thing. Stress, deformation, and strain. And I have mentioned that the maximum amount after this particular limit, the deformation might happen, was 500 Newton, which is quite a great amount, because a human cannot easily lift 500 Newton with their fingers. Whereas in this case, that was a main advantage which I found out. Another thing is that because of this ABS material which I'm using here, ABS material is something which nowadays people have started using commonly in the market. So in that case, this is giving a high rigidity. It's having a good temperature resistance. So around 150 degrees Celsius, it can go up till there. And also it is quite easier to manufacture with ABS material. So I feel this is one of the most economical way of going for it.
Okay, excellent. And when the user uses that, I'm sure they will also be using some kind of software. What kind of software will that be used, or the mechanism, will that be simple enough?
Yes, sir. We are going to use a simple software part. I'm still working on that as my research. So as I have seen that we need a particular microprocessor which will be having the software. So these signals that's been generated by our brain will be detected by the EMG sensor. This EMG sensor will easily give it to the microprocessor, but it's the microprocessor's work where it has to understand, should it like grip or expand or according to what it needs. So for that, the software is still going on. I'm coding it, but I haven't got the exact results which I'm looking for. And at the same time, for the feedback mechanism also, I am using another EMG sensor over there. Since our human body is one of the most advanced mechatronic system, learning this is one of the most complicated one. So to replicate the exact human body's mechanism is not easy, but especially the feedback mechanism, the sense of touch. So still working on the programming part, sir.
Thank you.
Yes.
The picture, if you have any questions from the participants, you can let us know, or if you can let us know about the time. John.
There is no question for Subiksha, sir.
Okay. John, do you want to ask another question?
Yes, just a thought. Is there a left hand and a right hand version of this, or are both the same?
There will be an inversion, sir, because the finger mechanism is quite going to be varied. For example, right now in the entire design, it was actually for the left arm because the shifting mechanism was on the right side, which is basically the thumb. Whereas in the right hand, it has to be on the left side. So there will be an inversion process, but most of the inside processes, like the programming, will be the similar ones.
Yeah, excellent. I thought so. Thank you very much.
Yes, sir. Thank you, sir.
Okay. If there are no more questions from the judges, so what you, Deepshika?
We do not have any questions on the chat box, sir.
Thank you.
Okay. Thank you so much.
Thank you.
Thank you, Dr. Unif. Thank you, judges, and thank you, Subiksha. I wish you all the best for your project. We will now proceed to our second presenter of today, who is from Mauritius. He is Mr. Krishnadev Pentaya, young activist and final year mechanical engineering student at the University of Mauritius. He will be presenting his project, the biomimicry canine front limb prosthesis.
Mechanical engineering has sprouted in so many different fields, some of which are used to destroy, others which are used to create and sustain. Life is no longer the way it was before. It makes future mechanical engineers like myself to ponder, why are we doing what we are doing? Where lies humanity in all of these engineerings? In around 950 BC, we discovered the oldest documented prosthesis. Later, a new field emerged, mixing human anatomical biology and mechanical engineering, a subset of biomimicry. Today, we are going to dive in this part of biomimicry to show how humanity was raised to another level when they implemented this technology by helping those next to us, our dear animals. I am Krishna Pentaya, currently doing my BEng in mechanical engineering. I'm also an activist and the founder of a youth-led environmental organization called Sauve la Nature. So today we're going to talk on something that really inspires me in mechanical engineering, especially the mixing of the arts with the science into fostering something beautiful, which we call biomimicry. Biomimicry is simply how we mimic existing biological structures into fostering them into the mechanical engineering. We're going to talk on how we can design a prosthesis for canine with front limb deformities. Leonardo da Vinci once said, I quote, "Where the spirit does not work with the hand, there is no art." And today we're going to dive into the world of artists and scientists creating engineering. In today's discussion, we're going to talk about the aims and objectives, especially, and different kind of front limb deformities and how amputations affect a canine throughout his or her life, existing models, customer needs, and we're going to see how we chose the different kind of materials. We did a finite element analysis and some engineering drawings, and finally how important those designs are in the aspect of our environment. The problem definition is quite complex, but not complicated. The canine Lupus familiaris, also known as the canines, are actually deemed the best friends of mankind. And unfortunately, one of the main reasons why people resort to euthanasia is mainly because of limb deformities. After having resorted to amputation, it is important to understand the rebalancing of the canine's gait. We call the canine's gait the way a canine actually walks or throttle or runs. Another problem is for the owner to understand how to use the canine prosthesis. Law and ethics is another problem that we could encounter. The affordability of the product, and finally, varying dimensions in varying canines. and creating a single product for all canines is quite impossible. So the aim is actually to design a resilient, economic, eco-friendly, comfortable and easily manageable canine front limb prosthesis to give them back the quality of life through partially restored locomotion and stability using materials which are easily available in the local market. The objectives are pretty simple. So we have to collect data analysis, method of surveying to gather information on existing methods, to analyze existing models, and to select appropriate materials which can be disposed in the most eco-friendly manner. To carry out a cost analysis of a proposed design and to design the prosthesis which could actually be adjusted for the canine. For the front limb deformities, we have different types of medical diagnosis. The first one can be angular limb deformities, where the canine limb are deformed in such a way that there is an angle difference. And the second one is antebrachial growth deformities. And the third one is dwarfism amongst our dear pets. So when we amputate, there are different kinds of levels of amputation, as you can see in the picture. There are the elbow joints, the radius, the ulna. So in our project, we are going to consider mainly amputation at the elbow joint. One of the most difficult prosthesis design is to design prosthesis for a canine from the elbow joint. So there won't be the ulna and the radius. Here are some existing models. We are going to visit the animal kingdom first, and then we're going to dive and specialize ourselves in our canine friends. There is a Chilean flamingo that I found really interesting. The leg is composed of a 7-inch carbon member. And we have the pony, Ange Marie. The pony is actually harnessed with a prosthesis, and the pieces were made of molds and from casts that formed the shapes of the leg. And you can see the third one, Caramel, is actually one of my favorites. Caramel is a squirrel with a prosthetic wheelchair. The apparatus is mainly composed of a small pair of wheel, shock absorbers using a spring, and finally straps that are attached to the equipment perfectly, the elephant's leg. Secondly, we have this endangered species of sea turtle. It's named Hofesh, meaning freedom in Hebrew. A green sea turtle was caught in a fishing net. Unfortunately, the turtle lost its flippers, front and back flippers. So firstly, the engineers actually inspired themselves from a fish dorsal fins and incorporated it in the turtle. Unfortunately, this was not the best solution because the turtle was not balanced properly. And then there came the concept of reverse biomimicry, where the scientists actually used existing technologies from this raptor warplane, and they chose it and placed it in such a way that the turtle would regain balance. Now we go back to our dear canine friends. You can see T.R. Short contributed in the history of animal prosthetics by constructing a mobile cart which would enable an animal affected by posterior paralysis or related conditions. The cart would enable the affected animal to move in a way and balanced completely self-propelling. And you can see the different components. There were mainly secured straps, buckles, and U-shaped frame. For the LG Parks model, it contained a hip support member where you can see above, connected together in a cross arms and upper end to the cart, also a transverse axle between the wheels and mounted on the bearing. The lower clamps and the upper ones are used to adjust the shaft. In the first existing model, you can see the partial limb prosthesis actually. The upward silicone socket is made using mold casting, and the straps are used to tighten up the prosthesis for the same not to detach. As you can see, the part that touches the ground is accommodated with rubber to absorb the shock. The type of prosthesis that you can see in the picture can be used only for mid-radius amputations, like we told earlier, the different levels of amputation. The canine would have to already contain the fixing area to fix the prosthesis. The second existing model is a front limb wheelchair for canine named Derby. It's actually not the ideal solution Unfortunately, the wheelchair would get stuck in deep terrains because of the imbalance of the design, and it was difficulty for Derby to maneuver. So they came up with a second existing model for Derby, a biomimicry 3D printed dual front prosthesis for underdeveloped limbs. Unfortunately, the prosthesis was of low level, and this created unwanted strain and stress for Derby's backbone. As you can see in the video, Derby had to curb while running. And finally, they got to create the perfect 3D printed biomimicked prosthesis for Derby with dual front limb prosthesis. They just had to raise the rubber prosthesis, and this remediated the fact that Derby's back was not straight. As you can see, Derby is running perfectly. And this prosthesis was for front limb deformity, curved deformity. As you can see, Derby's elbows are still here. The fourth existing model is about percutaneous fixation to skeleton. What is it? It's really interesting actually, where we get really diving into the biomimicry. So the first part of the element is fixed into the skeleton of a moving bone, and this is implanted into the bone, allowing normal gait, the canine's locomotion, without no limping. And this is actually connected to the exoprosthesis, and the exoprosthesis is actually the part that is maintained and changed if needed for this existing model. The Perfits is actually a state-of-the-art technology used for this kind of canines, which is really costly, unfortunately, because of the material, mainly titanium, is used. We identify the customer needs, mainly the product life and durability, ease of use, the space occupied, the maintenance, safety. One of the most important part that our customer pointed out was the weight of the product and how to use the prosthetics, because Mauritius actually is not used to such a product. In this vein, now we come to the beautiful part, the part that I actually enjoy the most and I'm pretty much passionate about, is the art part. Concept generation might not be easy when we do not know how to integrate different kind of components. So we design 3 different kind of concepts. So as you can see, concept A, it's a uni-wheel attachment that's actually resembled to the past patents that we saw for the rear limbs, but this one is for front limb. Unfortunately, this product is not ideal because a lack of balance for the product. The second concept would be the shank and transmission plate prosthesis. Now we can actually see in the picture, the concept is inspired by a real limb of the canine. It biomimics mainly, as you can see, the humerus part of the canine, the ulna and the radius bones, along with the paws and the knee joint. So the paw is an energy absorbing foot made up of rubber, and you can see also the knee shank plug and the rotating axis acting as the knee joint of the canine, and you can see also the socket acting as the upper part. The canine actually does not have the upper part because we are mainly considering a canine without the attachment part, whereby the amputation was done completely for the whole leg. So this is how the shank and transmission plate prosthesis is attached to the canine, and the transmission plate is actually used to absorb shock. It actually mimics the muscle of the canine. You can see here, as the weight of the canine during the gait, canine's gait, as the weight increases, the transmission plate gets compressed, and as the weight decreases, it gets retracted. So the plate has elastic properties, which actually helps it to transmit reactive forces smoothly to the socket connection. And this is how we mimicked the muscle. So you can see the metallic part actually mimics the bones, and the elastic part mimics the muscles. And the knee shank plug would laterally rotate the knee joint of the canine. So it would rotate in such a way that when the canine moves, it won't disturb the canine from properly getting its gait right. As you can see, the energy storing foot is actually a component which is designed to be triangular based for one to reach maximum stability compared to different other drone architectures. We have the final concept, concept C, which is a 3D printed two-piece prosthesis. The inner geometry too, as you can see in the picture, acts as the muscle. It compresses and retracts. And the elastic plate 3 is elastically compressible also for proper weight distribution. Unfortunately, it's not the ideal concept because when fixed to the canine, it would just act as a stationary component, as a stationary structure being there, quite much preventing the canine from moving. Material selection, we chose for the socket polypropylene, elastic plate nylon 66 because we can use nylon 66 in 3D printers, and for the shank, plug and pin, we chose aluminum alloy. The safety aspects are important to consider for any types of design, any types of products, especially when this product is not recognized for the market. The owner must take care whether there is slippery surfaces. The owner must know how to use and a little bit how to maintain the canine prosthesis. Also, collision or malfunctioning of the prosthetics, rejection of the prosthesis might occur in case it doesn't appear quite compatible with the canine's feelings. So loose attachment of the prosthesis is also a safety aspect that we need to consider. So we use SolidWorks to do some simulations, as you can see in the picture. We tried static analysis. So the static analysis quite showed on how the load is distributed on the socket and how both yield strength and displacement showed that the material used is quite okay. We have shown that the weight distribution of the canine is actually 25 kilograms as a whole, but is 30% distributed in the front limb. So one front limb contains 30% of the 25 kilogram. So 20 times 0.3 times 9.81, we get 73.575 Newton acting on this member. So the shank analysis and also the elastic pore analysis show that the yield strength and the distribution and the displacement are all okay to go forward for the design. We chose SolidWorks to make the drawings, and you can see an exploded view of the socket, which is actually harnessed to the canine, so the canine's bottom part, and the pin is actually connected to the socket, the knee shank and the shank itself connected through the pin, and all of those are joined together like a sandwich, and the elastic leg and elastic paw are actually fixed to the whole structure. It's important to consider the environment always when we design anything for anyone. So the life cycle assessment showed that the manufacturing part is actually really consequential for the carbon footprint because of the aluminum we are going to use. Thankfully, the aluminum can be recycled and used for a later stage. An improvement in terms of environment could be to use banana pseudostem epoxy composite instead of the glass fiber polyester in the socket, and also to use bambusa heterosnakia in the pylon, which actually has a high tensile property of 341 to 530 megapascal, resembling actually the shank properties. The main disadvantage is that bamboo cannot resist for more than 3 years due to deformation, but further studies are being done to look into how to treat bamboo for it to become more durable. Limitations and improvements, we actually have limited market, limited specific customers. Anyway, it is designed in a humanitarian purpose especially. So design for age, as the canine gets bigger, we'll have to change, for instance, the socket, everything to proportionately match the canine. And how far one is inspired by nature to design for nature. When we design for nature, we must take into consideration the carbon footprint left behind. So the biomimicry is inspired from nature, from the natural construct of the bones of the animal. But however, the carbon footprint left behind does not really mean that we are designing for nature. So we have those solutions for bamboo and banana research going on. And finally, the philosophical aspect can be a limitation too. Are people ready to accept such a product in Mauritius, for instance. Finally, I would end with this note. As future mechanical engineers, I believe we have to know our purpose and ask the question why we are doing what we are doing. So the inspiration behind this design project was my best friend, actually. My best friend named King, who was diagnosed with cancer and tumor in his right front limb, and we had to amputate. I remember my parents, the philosophical aspect, the mindset, not ready to amputate, but rather to resort to euthanasia. But we fought, philosophical clash at home. So we fought to keep my best friend alive, and he got a second chance to life, and this is for him that I chose to design the prosthesis. Unfortunately, 2 years later, just recently, he would die of old age, but he taught me courage and he taught me selflessness, and he taught me so many things that now I'm going to use this project, develop it further until it can be made use to future people. So thank you for your attention, and the need for humanity is really important, especially when we are scientists engineering for the future. Thank you very much.
Thank you, Krishna. I will now request you to unmute yourself and turn your camera on for the questions and answer session. Krishna, can you unmute yourself now?
Yes, good morning, everyone.
Hello, Krishna. We will now proceed to the questions and answer session. Dr. Puneet.
Thank you, Deepshika. Let's go to the first question, Peter Brewer.
Good morning, Krishna, or good afternoon. Presentation. I thoroughly enjoyed it, being a dog lover myself. First question really is, was SolidWorks the only package that you considered for designing the prosthetic?
Okay. First of all, bonjour from Mauritius. Yes, so SolidWorks was unfortunately the only package for both the finite element analysis and the design, because it was mainly a limitation because due to time constraint. The project was actually a design project, an assignment that was assigned to us, and there was limited time and technological resources. So we had to learn by ourselves how to use the SolidWorks, how to use all of these. But ahead of those simulations, ahead of using SolidWorks, we are definitely working further ahead of the project on ANSYS. And especially the thing that is really lacking here is a design of experiment to actually test the prototype, which we are actually, again, working further. So yes, we only use SolidWorks just because of the time constraint.
And a second question, you mentioned about using biofibers, I suppose, for the prosthetic. Is that with a standard resin mix, or are you looking at recyclable resins, which are now becoming available?
Yes, it's much more of a recyclable epoxy mix, where we are going to use the BPEC composite of banana fibers. which are actually very much available in Mauritius, especially right now we're being hit by a cyclone. If you see outside, much of the banana trees have fallen down. And at the University of Mauritius, the research, especially in the banana epoxy composite, is being very much favored by my dear fellow friends from chemical engineering and mechanical itself.
Thank you.
Thank you.
John.
Hi. Can you tell me a bit more about the market for this? And I think I'm interested in two things. First of all, what sort of research did you do into the market? And secondly, how do you see the market for this type of product developing?
Yes, thank you very much for your question, sir. So that's indeed a very important question for us engineers to sustain our products. So the first thing, the product is not mainly done for monetary purposes. It's mainly done for non-profit purposes. Just like I mentioned earlier, I am the founder of a youth-led organization here in Mauritius called Sauve la Nature, which means helping to save nature. And through that organization, we already have made a great network of canines, of different NGOs, different pet rescuers and veterinarians. So firstly, the networking is important for to get a view for the market. And secondly, for instance, just recently on Thursday, we rescued another canine whose rear limb was deformed, and he's currently going for veterinarian surgery on Monday. I thank my fellow friend who is here who had helped me. So secondly, the thing that is important to consider for the market is we actually did a social impact assessment and a survey with our networking. We accumulated 300 participants in the survey, dog owners, veterinarians. Those would be our customers, and especially pet rescuers, because they are the ones who rescue those kind of canines. So through those networkings, we finally managed to find, just right now, 7 probable future candidates for the same prosthesis. So in terms of the market, as I told you, it's not really designed for the monetary aspect. It's much more on a humanitarian perspective with the help of the organization. So it's much from a bigger picture perspective to work with one another for our dear friends.
Okay. Okay. Thank you.
Thank you.
DTM Sarfraz Nazir.
Yes, Krishna, thank you for your presentation. You mentioned that as the canine ages, that you may have to redesign it or change the size of it. How often do you expect to change?
Yes, thank you very much. So that's another limitation that I mentioned earlier. So according to the ISO standards under section, I think 2.2, unfortunately, there are no ISO standards regulated for canines, but there are those like my friend earlier presented, Miss Subiksha, I think, there are for the humankind. So under the WHO. So I followed those ISO standards under how to rebuild and how to maintain, and when especially to redesign for aging canines. So from our survey that we did, we had some questions asking about the age of the canines as well. And we recognized that mainly those deformities occur after the teenage time of the canine. So after the canine has been really much grown fully. So the most probable cases would be when a canine is fully aged, fully grown, because sometimes they encounter with accidents. The main reason why we amputate, according to the survey, is due to cancer. And those canines develop cancer at a later stage in life, so they will be pretty much grown up. But then if ever those canines, in the very minor cases, which we haven't got till now, the canine has been amputated since very small, then there will be, according again to the standards, some kind of a therapy It will start with a therapy, rehabilitation therapy for the life quality of the canine, and we will indeed have to redesign for the growth process. For example, when I showed Mosha the elephant, this is another example whereby the design had to be upgraded at least 2 times a year when Mosha grew.
Okay, you were showing us, you contacted your customers and they told you what kind of needs that they have. What kind of demand do you expect for this product?
So the demand right now, as I mentioned earlier, is actually only 6 candidates needing for a front limb prosthesis, but there are more candidates around, if I remember, 12, 15 candidates needing for the rare prosthesis, because the rare limb paralysis is more common than the front limb amputation. So for this only product, we have around 6 candidates right now just in Mauritius, but I'm really thinking to expand the market through our network, through the organization, especially just recently, thanks to COP26, we got to really connect with the world, especially Mauritius is a very small country, whereby it's at times very difficult to connect with the global world. It's much of a small village in the whole planet, a dot, but the passion to bring forward and to make people work together, engineers working together. I think this also would attract attention and would bring more customers and especially more demand.
Thank you, appreciate it.
Thank you.
DTM Qayyum.
Thank you. Thank you, Krishna, for the presentation. Condolences for your loss.
Thank you.
You talked about how you can expand this and how you can scale it and how you're trying to network. Where do you see it going forward? We talked about dogs, right? What's next? Are you thinking about any other animals at this point? So just share your thoughts about that, please.
Yes, thank you very much for your question. So I actually have an inspiration. There is a veterinarian in the United Kingdom who has very much inspired me, and his organization is called Bionic Pets. And he started with canine too from a very young age, and he went on to for other pets like cats and like Ange Marie, the horse that we saw earlier, the pony. So taking inspiration from his work, I am planning to also expand the same here. But in Mauritius, the most common example that we can encounter would be for canine friends and cats. But the difference is that cats can very much survive thanks to their flexibility and their kinematics, their different kind of motion. The survival rate and their quality of life is not very much affected compared to our canine friends. So for now, it's just for our canine friends. And for the future, I will try for our dear cats and other friends. And especially, it's important to consider, especially here in Mauritius, the price, because we are a country whereby the poverty rate is still here. We're still developing. It's very much difficult, for instance, for pet owners to afford such type of products. So we are mainly focusing on made in Maurice, like we say, things that are made here in the country, constructed here with the help of people here through the organization to sell it at a very cheap price.
Thank you very much, and please stay safe.
Thank you.
Thank you, Krishna, for your time. And we move on to Dipshika. Just let me ask her if there are any questions from the audience.
Yes, sir. So we do not have any questions for Krishna in the chat box. We can proceed.
Thank you. All the best.
Thank you, Krishna. All the best for your project instead, I would say. We will now proceed to the third presenter of today. She is Miss Nurey Mamadzada. She studies geophysical engineering at the Azerbaijani French University, and she is from Azerbaijan. She will be presenting on the topic renewable energy.
Hello, I am Rai Mamadzada, participant of SOPIC competition. In this competition, I will cover renewable energy, which is one of the ongoing topics in the world right now. So here is the outline of my presentation. First, I will give general information about renewable energy, then I will talk in detail about its sources, and at the end, I will give renewable energy sources in Azerbaijan. As it's known, all sources of renewable energy are used to generate electric power. Although not all of these sources are applicable in all countries, they can be developed and installed according to country's climate and landscape. The reason of developing renewable energy sources is that renewable energy is much more environmentally friendly compared to non-renewables. And by developing and relying on it, we can make our world a better place to live. Firstly, I will start with solar energy. Here is the process of getting electricity from it. Solar panels convert light or solar energy to electrical energy. When sunlight hits solar panels, solar cells absorb sunlight's rays and electricity is produced via photovoltaic effect. But this produced electricity is called direct current, DC electricity, and it's not suitable to be used in a house for appliances. Instead, the DC electricity is directed to central inverter of house or some building. Central inverter is here in the picture, and it's a device that's able to convert the DC electricity into AC electricity, which can be used at home. All households with solar are required to have a bidirectional meter or net meter. It's here. A bidirectional meter is able to record all the power that's thrown to the building, but also it can record the amount of solar energy that's exported back to the grid. This process is called net metering. Solar energy has advantages and disadvantages, and first I will start with advantages. Since you will be meeting some of your energy needs with electricity your solar system has generated, your energy bills will drop. As an example, the diverse exploitations of solar energy can be used to produce electricity in areas without access to the grid, to distill water in regions with limited clean water supplies, and to power satellites in space. Solar energy systems generally do not require a lot of maintenance. You only need to keep them relatively clean. As a disadvantages, solar panels are dependent on sunlight to effectively gather solar energy. Therefore, a few cloudy or rainy days can have a noticeable effect on the energy system. You should also take into account that solar energy cannot be collected during the night. If you want to produce more electricity, the more solar panels you will need. Solar PV panels require a lot of space, and some roofs are not big enough to fit the number of solar panels that you would like to have. Also, transportation and installation of solar systems have been associated with the emission of greenhouse gases. There are also some toxic materials used during the manufacturing process of solar photovoltaic systems, which can indirectly affect the environment. There are several developments in each renewable energy source in 2020 according to latest statistics. Major capacity increases are in China, 49 gigawatts, and Vietnam, 11 gigawatts. Also, US added 15 gigawatts. Japan added 5 gigawatts. Both India and the Republic of Korea increased solar capacity by more than 4 gigawatts. And here is the interesting fact about solar energy. Here is the image of world map, and there's green region on Africa part. That green region has an area of 300,000 kilometers square, and it's enough area for providing solar energy demand for entire world. Of course, this number is just hypothetical. To make this kind of energy systems, people need more infrastructure and other stuff. And here is the map of Azerbaijan with its green region that shows the same thing and as in the world map. Now I will talk about water energy. And here is the picture of process of getting an electricity from water. People use dams to block the water's natural flow. When the water is released, the pressure behind the dam forces the water downpipe, which is called the penstock. This causes the turbine to turn, and as a result, turbine turns a generator, which makes electricity. And here is the advantages and disadvantages of hydroelectric power plants. Hydroelectricity helps to fight climate changes. The generator that produces electricity in the plant doesn't release emissions into the atmosphere. Hydropower is also by far the most reliable renewable energy available in the world. When there is no sun or wind, people are not able to get solar or wind energy. However, water usually has a constant and steady flow 24/7. Hydro plants can actually change the flow of water, and this allows the plant to produce more or less energy when it's required or not needed. And as a first disadvantage of hydropower, dammed water source prevents fish from reaching their food, which is important for them, and has bad impact on fish. Although the generator doesn't produce emissions, reservoirs that are man-made lakes emit harmful gases such as carbon and methane. When dams are built at higher levels, they may cause serious problems to any town nearby that's below it. While these dams are built very strong, there is still risk of flood. As the world broke its record in 2020 by developing renewable energy sources, there are some in hydropower also. Growth in hydropower recovered in 2020, with the commissioning of several large projects delayed in 2019. China added 12 gigawatts of capacity and Turkey 2.5 gigawatts. Third type of renewable energy is wind energy. And in the picture, it demonstrates the process of getting electricity from it. A wind turbine converts wind energy into electricity using aerodynamic force from the rotor blades. When the wind flows across the blade, and this causes the rotor to spin. The rotor connects the generator that speed up the rotation and allow for a physically smaller generator. This translation of aerodynamic force to rotation of a generator creates electricity. Then this electricity is transferred to the grids. As other types of renewable energy sources, there are also advantages and disadvantages of this energy type. Actually, wind farms and individual turbines can be expensive to install. However, operational costs, in other words, OPEX, are relatively low. Their fuel, which is wind, is natural occurrence of nature, and turbines do not require. So the turbines do not require too much maintenance over the course of their lifetime. Cumulatively, wind farms can take up a lot of land space. However, the actual turbines and equipment do not use up a lot of space. This means that land used for wind turbines can often also be used for other purposes, such as farming. However, wind energy is intermittent. That means a wind turbine's effectiveness in generating electricity depends on the weather. Thus, it can be difficult to predict exactly how much electricity a wind turbine will generate over time. Wind turbines have some negative impacts on their surrounding environment also. A wind turbine's blades can harm and kill species that fly into them, like birds. Wind farm development can potentially damage local species' natural habitats if it's not done in a responsible way. Wind expansion almost doubled in 2020 compared to 2019. China added 72 gigawatts of new capacity, and United States added 14 gigawatts. 10 other countries increased wind capacity by more than 1 gigawatt in 2020. Sorry. Next, I will talk about geothermal energy. Here is the picture of geothermal power plants, and now I will explain the process. Heat from the Earth's crust warms the water that has spread slowly into underground reservoirs. The temperatures of water increases and it breaks Earth's crust and surface and appears as a steam or hot water. And geothermal power plants use this steam to produce electricity. The steam rotates a turbine that activates a generator. There are three types of geothermal power plants. As you see here, dry steam, flash steam, and binary steam. The process of dry and flash steams are same with the process I just explained. However, binary steam differs from other two. Binary cycle power plants operate on water at lower temperatures of about 225–360 Fahrenheit. In this power plant, two types of liquid are used unlike other steams. Binary cycle plants use the heat from the hot water to boil a working fluid which has a low boiling point. And here is the pros and cons of geothermal energy. First, while we cannot currently use most reservoirs, there is still hope that the number of exploitable geothermal resources will increase with ongoing research and development in the energy industry. It's estimated that geothermal power plants could provide between 0.0035 and 2 terawatts of power. Geothermal provides a reliable source of energy. This is because the resource is always available to be tapped into, unlike with wind or solar energy. Since geothermal energy is a naturally occurring resource, there is no fuel required, such as with fossil fuels. The main disadvantage of this energy is that its location is specific. Geothermal plants need to be built in places where the energy is accessible, which means that some areas are not able to exploit this resource. In enhanced geothermal power plants, there is a risk of triggering earthquakes because they force the water into earth crust with more tension. Geothermal energy is an expensive resource to install, with price tags ranging from $2 to $7 million for a plant with a 1 megawatt capacity. Now I will give little information about improvements in geothermal energy. Very little capacity added in 2020. Turkey increased capacity by 99 megawatts, and small expansions occurred in New Zealand, in the US, and Italy. The reason behind such a little increase might be the number of specific locations where this energy resource is accessible. And finally, I will talk about biomass energy. And here is the process of getting an electricity from biomass. Biomass can be burned to release its stored energy, or it can be converted to other usable forms of energy. Biomass stores energy from the sun as chemical energy, and when it's burned, it's released as heat. Plants absorb the sun's energy through photosynthesis and convert carbon dioxide and water into nutrients. The heat produced from directly burning biomass can then be converted to electricity for household usage. This energy source doesn't produce carbon dioxide because it's carbon neutral. Carbon neutral means that carbon that's released by burning biomass was already part of nature, therefore it cancels out. Biomass energy can be converted into many different fuel sources, each of which has varied applications. For instance, biomass can be processed to create biodiesel for vehicles. Biomass fuels are abundant also. Much like with the sun and water, they can be found practically anywhere on the planet. And this guarantees that people will not run into the issues, unlike fossil fuels. Burning biomass creates pollution of a number of different compounds other than carbon dioxide. Even though it's renewable energy, it's hard to claim that it's totally green. Biomass also leads to deforestation. It's also not as efficient as other energy sources, such as fossil fuels and nuclear energy. And the final problem is that it's expensive. Biomass energy's net capacity expansion fell by half in 2020. But bioenergy capacity in China expanded by over 2 gigawatts. Europe added 1.2 gigawatts also. And that was similar to the increase in 2019. Now I will give information about Azerbaijan's renewable energy. Azerbaijan is a country with huge potential for renewable energy development. The country offers abundant wind and solar resources, as well as significant potential of biomass, geothermal, and hydropower. The geothermal has set a goal. The government has set a goal of adding 420 megawatts of renewable energy capacity by 2020. As a result of this goal, the country has begun to deploy renewable energy projects via engineering, procurement, and construction. Azerbaijan's technical solar power potential is around 23,000 megawatts. The best resources for solar energy are in the central river valleys and in the north and northwest of Azerbaijan. Azerbaijan has around 3,000 megawatts of technical and around 800 megawatts of economic wind power potential, according to Ministry of Energy of Azerbaijan. The best resources are along the Caspian Sea, particularly on the Absheron Peninsula, the region right here. Hydropower is currently Azerbaijan's primary source of renewable energy, but its potential has not been fully exploited. According to Ministry of Energy, the technical potential for small hydropower is 520 megawatts. Azerbaijan's geothermal energy potential is estimated to be up to 800 megawatts. Initial studies indicate that Azerbaijan has 11 geothermal zones with water temperatures ranging from 30 to 100 degrees. The Ministry of Energy estimates technical potential of biomass energy to be 380 megawatts in Azerbaijan. And here are the sustainable regions of Azerbaijan for different renewable energy sources. On the map, red TV sign here shows central control service. Blue TV signs, however, indicate regional control service of energy. Other small signs are symbols of renewable energy types, respectively. And under the map, there is a table that shows potential capacities of each energy source throughout previous years. Azerbaijan's renewable energy potential offers numerous benefits for the country, which will only grow as technical advancements make renewables more affordable. Wind and solar power are considered the most cost-effective types of new generation in many countries, and in Azerbaijan also. Personally, I want not only Azerbaijan, but also the whole world to utilize renewable energy sources more than non-renewable, to protect our world from global warming, pollution, and other problems like that. Humankind have to work on enhancing renewable energy sources. And thank you for your attention and thank you for listening. That's the end of my presentation.
Thank you, Nurey. I will now request you to unmute yourself and turn your camera on for the questions and answer session.
First question by Peter Brewer.
Nurey, thank you for that presentation. Just a few questions for you. With biomass, you said it's carbon neutral. Is that taking into account the whole cycle, i.e. where you collect the biomass from the forest and then create it into whatever media you're going to use to burn, i.e. pellets or dust or whatever, transportation?
Hello, first of all, hello to everyone, and thank you for giving me opportunity to participate in this kind of competition. As an answer to your question, carbon dioxide, I said in the presentation that in the plants, in the leftover plants, that they cancel out because in any way, environment, when we burn the biomass, they produce, they both emit carbon dioxide and give us electricity. As a circle, of course, there is carbon emission, but not biomass itself. From other processes, there might be carbon emission in the environment.
Okay, thank you. And when you talk about wind, are there ways that we can assess how much generation we're likely to get from a wind farm over its life?
We can get more electricity from wind farms, both from onshore wind and offshore wind farms. I think up to 800 megawatts we can get from wind farms. That's it.
Sorry, I didn't explain my question very well. What I'm trying to get at is, when we decide we want to build a wind farm, how can we assess roughly how much electricity that wind farm will generate?
We can assess that with the region's climate, with the wind flows in that region, in that land. It's depending on land. So I want to say that if we install that wind turbines, the constructors first look at the region's wind flows, and according to that wind flows, yearly wind flows, they can estimate how much electricity could be generated, and according to that, they can install wind power.
Thank you.
Thank you so much.
Okay. Move on to John.
Okay. Thank you very much for that very interesting overview. You went through a whole series of different options, and you explained the advantages and disadvantages. I guess there are two questions. I don't recall you mentioning tidal energy, the use of the sea to generate energy. Was there a reason why you didn't include that? And the second question is, in all this range, are there going to be winners and losers? Which are going to be the big ones going forward? Which are the ones that we're going to see less of because other options are better?
Thank you for your question. The reason why I didn't include tidal energy is that it is kind of it's one part of hydropower. I generally explained hydropower, and tidal energy is not the most known type of renewable energy. The most efficient ones are the 5 types of renewable energy: solar, wind, water, geothermal, and biomass. I want to just talk about the main energy sources, and in my opinion, in the future, most usable renewable energy will be solar and wind, biomass wind energy, and what we will see less it will be geothermal, because, as you know, it's location specific. We cannot install geothermal energy in all parts of the all parts of the world, and not all countries are able to install that. I hope that I answered your question fully.
Yep, excellent. Thank you very much.
Yeah.
Okay. And Nure, we go to Peter Brewer for his question.
Sorry, Nure, I just thought of another question. In your presentation, you didn't mention anything about hybrid renewable sources. Did you consider that in your study?
Could you repeat the question? Your voice was cut.
Sorry, yes. You didn't mention anything about hybrid renewable sources, where we use different types of renewable energy to supplement each other. Did you consider any of that? Sorry.
When I searched, I mostly saw these 5 types of renewable energy. That's why I haven't heard about that. Maybe that's why I haven't researched about it.
Thank you.
Okay. Noor, you mentioned about geothermal being expensive energy, about $7 million a megawatt hour. Where do you think why do you think is it so high?
Because geothermal power plant capital expenditure is really high. For installing a geothermal power plant, there should be much more money to install this kind of huge turbines, generators, and other devices that would help to get electricity from that. And also, geothermal energy, as I said before, cannot be installed everywhere. Its location is really hard to find specific locations for that, and that's why it's really low.
Can you make a comparison between this cost of geothermal? I guess most cost will be for the drilling cost, because the rest of it is all same. Turbines, you have turbines, any plant will have turbines, but it's like drilling cost is going to be a significant one. But have you compared it with other costs for fossil fuel or other technologies?
I compared with the other renewable energy sources, not fossil fuels. As in, among all other 5 types of renewable energy sources, I think geothermal is one of the expensive ones. But other non-renewables, I haven't concentrated on them.
Okay, John.
I want to come back to what you said about solar energy, because if I understood you correctly, you see this as one of the winning technologies going forward. One of the disadvantages was to do with space, the amount of space required. And I'm thinking that, generally speaking, where you have high energy demand is places that will be highly populated, so you have very little space. But where you've got, you mentioned the desert areas where there is a lot of solar energy, but very few people. How do you see this going forward politically and commercially? Do you see desert states selling their solar energy to other countries, or how do you see this working?
I think yes, because in deserts there are solar thermal energy that is mostly used for heat, and in deserts there are much sun, and that's why and there also, as you said, there are less people living, and there it's easy to install more solar PV panels, and to get electricity from the sun. And why we need more space? Because we need more electricity to just equip other regions with solar energy and solar with heat.
Okay, thank you.
Thank you. Have you considered which one of these energy sources are best for residential purposes?
I think solar and biomass energy are my favorite ones, because biomass energy is applicable in everywhere, because every country, every part of the world, there are leftover plants, there are and from there about biomass energy. For biomass energy, the source is abundant everywhere, and solar energy also we have solar. Sun is renewable. It will we will not run out of sun, and as I did in my as I read in my research, solar sun gives heat and makes just helps people to produce more electricity, and it's cheaper to install that than other renewable energy sources.
Thank you. Thank you for your response and for your presentation.
Okay. Thank you, Nure. I think that's all what we have time for. Over to you, IMechE.
Thank you, judges. Thank you, Dr. Unib. Nure, we have a few questions for you in the chat box. We have the first question from Ahmed Ali. He says, you mentioned that the hydropower plants emit carbon dioxide and methane. Can you please elaborate on how this happens?
Could you repeat the question?
You mentioned that hydropower plants emit carbon dioxide and methane. Can you please elaborate on how this happens?
Yes. Hydropower itself doesn't emit hydrocarbon emissions, but when people build large dams, there are lots of plants under the water, and they produce that carbon emissions because they are getting dirty by this building dams, and that's why from that plant there is hydrocarbon emission.
The picture, may I suggest that because we have run out of time, so you can take down the questions, pass it on to Nure, and she can respond, and then you can pass it on to the respective questioners.
All right, sir. So, Nure, I would request you to answer the questions on the chat box itself, because the time limit is over for the questions and answer session. Thank you.
Thank you.
All right. Thank you, judges. Thank you, Dr. Unib, and thank you, Nure. No event is successful and complete without its audience, and hence we would like to thank you for being with us today. Your presence itself is a great support to our competitors who have been working so hard to be able to make it to this level today. I personally feel honored to be among such talented future engineers, and it was my pleasure accompanying you all till here. The journey does not stop here though. Sophie will be resuming shortly after a 15 minutes break with Suleiman by your sides. Thank you everyone and see you all soon.
Welcome back, everyone. We will now resume the event. Before proceeding, allow me to introduce myself. My name is Suleiman Ahmed, and I will be your host for the second half of today's event. I am a student of mechanical engineering, currently in my third year at the National University of Sciences and Technology located in Islamabad, Pakistan. I presently serve as the Public Relations Officer for the IMechE student chapter at my university. So far, we have seen three brilliant ideas being presented by three of our contestants. Proceeding towards the second half of the competition, we have three more excellent presentations in store for you. Our fourth contestant is Mr. Noman Afzal from Pakistan. Mr. Noman is a mechanical engineering student at the University of Engineering and Technology, Texala. He will be presenting his idea on Falcon X, the leak detection system.
Assalamu alaikum ji, I'm Noman Afzal from Mechanical Engineering Department of the University of Engineering and Technology, Texla. I'm a final year student and my registration number is 17ME144. And the topic that I'm going to present today is Falcon X. My ID card, university card. The highly accurate devices that we come across in our daily life are highly sophisticated ones, and the simpler ones have, of course, a limitation on their accuracy. Is it possible to have a device that is highly accurate and precise and is also simpler one? Well, I say, is it too much to ask for both? With that in mind, I humbly present the crown jewel of leak detection system, the device that uses helium sniffing, also known as helium bombarding technology, to sniff out the leakages. It is often said that high precision and accuracy can only be achieved at a cost of sophistications. Well, I respectfully disagree with that. I prefer simplicity in itself is the ultimate sophistication. With that in mind, with that being the basic thought, the basic idea, I designed Falcon X. So without wasting any further time, for your consideration, the Falcon X. That is actually the device, the leak detection device that uses helium sniffing technology to detect the leakages. So let's see what is happening behind the curtains and see this masterpiece in action. Fortunately, there were no casualties during that accident. The pilot safely got ejected. But what if he was unable to do so? As we can see in the video, the pilot landed only few meters away from the crash site. He actually had a 3-second window to save his life. In the first second, he pulled the ejection belt, and the next moment plane was down. To be more precise, he only had 1 second left to save his life. And surprisingly, that 1 second was totally depending on the ejection seat, which is actually nothing without the explosive that is fitted beneath it. Actually, it is the explosive that allows the ejection seat to move the pilot away from the plane as far as possible, as quickly as possible, as soon as the pilot pulls the ejection belt. So it is imperative to discuss the working of these explosives, the importance of these explosives. For instance, consider this is an ejection seat and this is an explosive. It is fitted beneath the ejection seat. This explosive is sealed inside a capsule that is airtight. For instance, this capsule gets a leakage, a small leakage. What will happen? Air will get inside this capsule along with the moisture content. It will disturb the optimized condition for this capsule to work properly, for this explosive to work properly. Now, if this defective capsule was fitted in the plane that was in the video, the pilot would have lost his life. So these type of sensitive devices must be tested with highly reliable, precise and accurate machines, as it is a matter of life and death, and we are talking about human life here, and we can take no chances on that. The basic idea for this device actually came from a puncture shop. Well, it is quite amazing to see how punctures are located inside the tube. The tube is filled with pressurized air and then it is checked underwater for air bubbles. When we get air bubbles, it means that we have located the puncture and the puncture is repaired. Similar type of approach is used for this device. In the first part, the sample is subjected to pressurized helium. Now, if this sample is defective, it is faulty, it has a leakage in it, this helium will get inside this sample. In the second stage, that the sample is placed in a helium detector. Now, when the sample is placed in a helium detector, it is exposed to atmospheric pressure. And at this condition, the helium that got inside the sample in the first stage will rush outside the sample. That will be detected by helium detector. Now, if helium detector detects the helium coming out from the sample, it means that there is a leakage in it due to which the helium got inside the sample in the first stage and it is now coming out from the sample in the second stage. So, if the helium detector detects helium coming out from the sample, it is a clear indication that there is a leakage in it and the sample is faulty. Otherwise, it is good to go. FalconX is basically a device used for testing leakages. In the first stage, the sample is subjected to vacuum, and in the second stage, the sample is subjected to pressurized helium. Primarily, the sample is subjected to vacuum to create some optimized and effective condition for helium to get inside. Actually, subjecting it to vacuum in the first stage will create a sort of negative pressure inside the sample if this sample has a leakage in it. And in the second stage, when it is subjected to pressurized helium, that negative pressure will allow the helium to get inside the sample more easily and we will get clear results. The device has a vacuum gauge and a pressure gauge for monitoring vacuum in the first stage and pressure in the second stage. As far as factor of safety is considered, while doing our calculations and calculating the necessary, the reasonable parameters like volume, pressure, weight, an extra factor of safety was kept. Actually, all of these parameters are totally depending on thickness of the material that we are using. And by default, when we visited the market, fortunately, we got the materials that were actually had 4 times more thickness than that was calculated by us. So no compromise has been made on quality, safety, and accuracy. The device is quite easily operable and can be moved from place to place. Keeping in mind the need for maintenance, the device has been designed in such a way that the worker can access the parts that are packed inside the trolley by removing the lids of the trolley, and they are clearly and easily accessible without any difficulty by the worker. Coming to the working of FalconX, that is actually the trolley and the system is packed inside the trolley except for the chamber. Up top right here is the chamber. The sample will be loaded in this chamber. Packed inside that trolley is the buffer. That right here is the buffer, and on the side of the buffer in the red color you can see the pump that is used for actually creating vacuum inside this chamber. The pump is directly connected with the chamber and the buffer is also connected with the chamber for providing pressurized helium. The buffer contains pressurized helium to supply it to the chamber in the second stage, and the pump provides the vacuum to the chamber in the first stage. Now coming to the chamber on the up top has a lid right here. The lid is removed, sample is loaded inside the chamber and lid is closed. In the first stage, the sample is subjected to vacuum that is provided by the pump, and in the second stage, the sample is subjected to pressurized helium that is provided by this buffer. This buffer provides this chamber with pressurized helium, and after that this lid is again removed, sample is taken out and it is placed in the helium detector. And if the helium detector detects the helium coming out from the sample, it means the sample is faulty, otherwise it is good to go. Basically, Falcon X has three parts. Up top is the chamber for loading the samples. Placed beneath the chamber, packed inside the trolley, is the buffer that is connected with the chamber for supplying pressurized helium. And the third part is vacuum pump that actually provides the chamber with the vacuum that is needed for stage 1. Samples are loaded inside the chamber. The chamber is made of stainless steel and has two gauges on it. Vacuum gauge and pressure gauge for monitoring vacuum in the first stage and pressure in the second stage. While considering the interior design of the chamber, it involves two removable meshes. These meshes serve a great purpose for testing multiple samples and also for accommodating some irregularly large sized sample. For example, if we come across a sample that is quite larger in size and has also an irregular shape, we can remove the meshes and place the sample inside the chamber and can test it. On the other case, if we come across some regularly shaped small sized samples, we can place multiple samples on the meshes and can test multiple samples inside the chamber at a time. The purpose of the buffer is to provide the chamber with a controlled supply of pressurized helium. It also provides the chamber with multiple refills, and like chamber, the buffer is also made of stainless steel with a pressure gauge on it. Now a question is there that why are not we directly using helium cylinder instead of buffer? The answer is quite simple. Controlled supply of pressurized helium. We know that chamber is again and again subjected to vacuum and pressure. Due to this, a cyclic stress is produced. And if the chamber is connected directly with the helium cylinder, the value of this cyclic stress would be much greater as the chamber is again and again hit by large pressure. That would be very damaging to the life of the chamber. No doubt, no doubt in the case of buffer, the cyclic stress is also there, but this time it is with controlled, reasonable and safe pressure, which would prolong the life of chamber. Packed inside that trolley along the side of the buffer is the compressor. This compressor is directly connected to the chamber via a pipe. The main purpose of this compressor is to provide the chamber with a vacuum for stage 1. Some of the components involved are pressure gauges, delicate vacuum gauges, pipings and fittings, trolley, and some of the processes involve CNC machining also. So the present cost of the device is almost 5 lakh rupees. While some of the applications do not require that much accuracy, so the cost of device can range between 3 lakh to 5 lakh rupees. However, if the mass production starts, the same quality device cost that is presently 5 lakh rupees can be reduced to 4 lakh rupees. First of all, the sample is placed inside the chamber. Then it is subjected to vacuum. Afterwards, it is subjected to pressurized helium from buffer to chamber. The sample is taken out, and then the sample is placed in helium detector for detecting any possible leakages. Let's see the technical details of buffer and the chamber. The first two images show the 3D rendered model for the buffer. The next image shows the technical drawing of the buffer. And the third image shows the actual manufactured buffer. This is the 3D model of the buffer. This is the orbital view of the buffer. This is the exploded view of the buffer. The exploded orbital view of the buffer. The first two images are the 3D rendered model for the chamber. The next image shows the technical drawing of the chamber, and the third image shows the actual manufactured chamber. This is the 3D model of the chamber, the orbital view for the chamber, the exploded view for the chamber, the exploded orbital view for the chamber. Now for the whole assembly, this is the model of the whole assembly, the orbital view of the whole assembly, the exploded view for the whole assembly, the exploded orbital view of the whole assembly. The links to all these models are shared at the end of the video. You can just put the link in the search bar and you can try all these options at your own ease.
This is the 360 roundup for the device, the Falcon X. I know my video making skills are not that good, but it's just a request to please bear with it.
The device finds its application in aerospace industry. As it was discussed in the first slide, that ejection seat use a capsule that contains explosive. These capsules can be tested with this device. Some of the military equipments can also be tested with this device, of course, if you want to avoid an unexpected blast. The automotive industry has some airtight shock absorbers that can also be tested with this device. In the electronic components, some of the components like thermostats, switches can also be tested with this device. And the packaging, especially the medicine packaging, where moisture is seriously avoided, this device can play an important part. The device does not interfere with the geometry of the sample that is to be tested. There is no need to disassemble the sample before testing it, so it is non-destructive. It is quite user-friendly as anyone can easily operate it after reading the instruction manual. The device is sensitive since it involves some delicate vacuum gauges. As far as its accuracy is concerned, it is very accurate. The device can detect a leakage of diameter up to 0.07 nanometer. And for comparison, a hair has a diameter of 1 lakh nanometer. Keeping in mind the easy handling and its portability, the device is quite neatly and compactly packed inside a movable trolley. Now we will practically see some of the consequences of leakages.
Mark. Mark. ¡Mister! Granada en la boca de juego. A mi orden, cuando listos. A su orden. Juego. Juego.
Well, that was all from my side. Thank you so much for your time and patience for listening to my presentation. Questions, please.
I will now request Mr. Noman to please turn on his microphone and his camera for the question and answer session, which will be overseen by Dr. Uneeb.
Right. While we are waiting for judges to raise their hand, I've got this first hand raised, Peter Brewer.
Thank you, Namal, for the presentation. A few questions for you.
So, sir.
As it's a pressure vacuum device, presumably it's been designed to certain ISO standards.
Yes, sir, it is.
Do you, or can you name those standards?
Actually, sir, I'm not very well aware of that field in detail, but it is designed to the ISO standard, sir.
Okay. And presumably will require pressure testing at certain intervals to meet those standards?
Sir, can you please repeat the question?
If it's designed to ISO standards, then presumably the equipment will need to be placed through pressure testing standards as well.
Yes, sir, it is.
Is the device able to be pressure tested, or does it use the existing fittings?
Actually, sir, I'm not getting your question. Can you please repeat? I think it's a signal issue.
Yeah. Would the device, in order to be pressure tested and vacuum tested, would it be using it through the existing fittings, or does it need additional fittings in order to enable that?
No, sir, it is using the fittings that we have used are good with that pressure testing, sir. No additional fittings needed.
And do you see this being able to be scaled up for larger items?
So we have to customize the design a bit, but yes, sir, there is a chance of scalability.
And it was designed with military use as a primary use?
Sir. Yes, sir. It was specifically targeting that use, sir.
Okay. Thank you for the presentation. It was well presented. Thank you.
Thank you so much, sir.
On to John.
Hi. I've got two questions, one technical and one non-technical. The technical one's always easier. In terms of pressures, what sort of pressures are we talking about?
So we are talking about the pressure range of 0.01 bar to 2 bar pressure. That is basically the operating range of the chamber.
Yeah, we're not talking about huge pressures.
No, sir, we're not talking about the.
We're only talking about two bar. Now, the non-technical question. I'm fascinated by the idea of using helium as the means of doing leak detection. Is this a novel idea, or are there already devices out there which are using helium as a means of leak detection for this sort of device? If it's novel, Can you tell me where the inspiration came from? If it's something that's already existing in the market, what's the advantage of this one over the ones that are already existing?
Sir, actually helium, the devices that use helium are already in the market, but sir, the mechanism is quite different and they're also quite expensive. And if I'm talking about Pakistan, it is the first one in the Pakistan to use helium and such mechanism to test these devices.
Yep. Yep. And in terms of packaging, you're looking at medical packaging. Do you think there are other possibilities for things like food packaging, for example?
Yes, sir. There are possibilities. That's why we designed the meshes. That totally depends on the size of the sample that we are about to test, sir.
Yep. Very good. Thank you very much.
Thank you, sir.
DTM Kayyum.
Thank you, Dr. Neeb. Mr. Afzal, thank you for the presentation.
Thank you, sir.
First question, what is being used right now for testing the devices that you're trying to test with your solution? Is there anything that we're doing to test those devices?
Sir, can you please repeat? I'm getting some problem on us.
The question is, how are we checking leak right now in those devices that you're proposing for the prime use case for your device?
Yes, sir. Sir, actually, these devices are the devices that I targeted building this device. These devices are go abroad for checking. They are not. There's no device available in Pakistan for checking these devices, so they go abroad for checking. This is the first one, sir.
In Pakistan.
And we have successfully checked, sir, almost 10 to 12 samples on it.
Okay, very good. Thank you. Second question, you mentioned automobile industry as one of the use cases for your device, correct?
Yes, sir.
So explain how that would work. I mean, do you remove a component from a vehicle and then test, or do you test before the component is installed?
So the component has to be removed and has to be put in the chamber. So it must be removed. And if you want to put in the chamber, that's obviously, if you want to test it, you must put it in the chamber. So it must be removed from the vehicle, sir.
Okay, thank you.
Thank you, sir.
DTM Sarfraz.
Thank you, Numan, for your presentation. What's the plan for marketing this Falcon X?
Sir, actually, I designed this from the mechanical engineering perspective, but we designed this project under the supervision of a government organization in Pakistan. So marketing is totally up to them, sir.
Okay, I see. So right now you've been focusing on the military side. So has any experiments been done for non-military equipment testing?
Sir, sir, we are just about to start those experiments on the non-military side. We have just went through the military perspective from the military cartridges that we have tested, but to be honest, it hasn't begun yet, the non-military side. But yes, surely we will start the testing.
Okay, thank you. Appreciate it.
Thank you, sir.
John?
How did you come up with the idea in the first place? You seem to talk a lot about military applications. Was there an approach from the military looking for something like this, or did you just wake up one morning with this inspiration that this is what you wanted to do? How did you come up with the idea in the first place?
Sir, actually, we were assigned a problem in our final year project, and we examined all the systems that are already available and the market as well, and the systems abroad that are available, and similar systems of this type. So we merged up all that concept, sir, and came up with this.
When you say you were assigned it, did this come from a source, or was it just the brainchild of a member of staff or something?
I'm sorry, sir?
When you say you were assigned the project,
Yes, sir.
was this something that the university had been approached to look at, or was it just the brainchild of a member of staff or something like that?
No, sir. Actually, university was not approached. We had this organization that's government organization, and we went to them to get a final project done. They assigned us this problem, sir. So we worked on it. It almost took 1 year and 3 to 4 months, I guess, to come up with this.
Okay, very good. It's always easier to develop something when somebody actually wants it. So that's good.
Thank you, sir.
Norman, this sensor that you use when you put the sample in the box and use sensor, which sensor are you using? Which sensor is this? Is this like some already OEM, more than one OEM, original equipment manufacturers are there for this, or you have any specific organization that you're using some testing device?
Sir, are you talking about the helium detector, the device that detects
Yes.
the helium?
Yes,
Sir,
in the
actually it's a Chinese company, Yulvac, that designs this helium detector systems. So after taking the sample out of the chamber, we put it directly into that detector, and it gives a positive or negative signal, sir.
What is the accuracy of that?
Sir, it has an accuracy. If you are talking theoretically, it has an accuracy of you can say the atomic size of helium. If you're talking about that, I mean, it can penetrate a leakage of up to a size of an atomic radius of helium, atomic size of helium. So it's
Yeah.
quite accurate, sir.
Okay. Peter Brewer?
Norman, what's the life expectancy of the analyzer?
Sir, the life expectancy totally depends on how you are using this device. If you are using it for the application that I targeted, that's military applications, and that do not require that much pressure, so it can last up to say 10 to 12 years.
And, sorry, I didn't explain myself very clearly. I mean the helium
Yes, sir.
analyzer that you're talking about.
Yes, sir.
How long will that last? Because you're presumably subjecting that to sort of pressure and vacuum.
Sir, if I'm not wrong, you're talking about the helium analyzer, and I've told Sir Unip that the helium analyzer is basically a Chinese company that we're getting the helium analyzer from. The system is separate from the helium analyzer. It just creates vacuum and pressurizes the sample. The helium analyzer is another thing, sir. So I'm not sure about that helium analyzer, sir.
Okay.
Thank you, Naman. Your time is up, and over to you, Suleiman.
Thank you, sir.
Thank you, everyone, and good luck to the participant for his project.
Any
We'll now
questions? Any questions from the audience? Kindly forward it to Naman for him to respond back.
Sure, you can send me the chat box.
Thank you.
Right. So up next, we have our fifth contestant for the event. He is Mr. Samson Ojum from Nigeria. He studies mechatronics engineering at the Federal University, Otuoke, and will today be presenting his topic of ensuring quality assurance through computer numerical control.
Good day, everyone. My name is Samson Ekagem Kosemojum from Federal University Otueke, Bayelsa State, Nigeria. I'm here to present my topic, which says quality assurance through computer numeric control. Here's my outline. The advent of computer-aided manufacturing has revolutionized the manufacturing industry. The advantage of a computer-based technology is its precision, accuracy, less fatigue, repeatability, speed, and multitasking, and its ability to work in hazardous environments. To ensure quality, having all manufacturing process being governed by the computer will be of optimum advantage, as the management of materials and resources will be ensured. So this presentation proposes a low-cost computer numeric control machine for making new products from recycled plastic bottles. Now, what is quality assurance? Quality assurance can be seen as a management method that entails all planned and systematic actions needed to provide adequate confidence that a product, service, or result will satisfy the given requirement for quality and be fit for use. And also, graphically, it can be seen as the process of planning, executing, cross-checking, and acting. So it could be a flow chart of plan, do, act, check, and act. You plan your steps you wish to achieve quality, you execute those steps, you check if those steps gave you required results, then you act. If it doesn't give you required results, you repeat the process. If it gives you still market the process, but you also check how to make your product very okay for. Now, computer numeric control entails numeric code known as numeric coding known as G&M code, which is used to control the movement of a tool in relative to a workpiece with the help of the computer. Now, before now we had lathe machines, conventional lathe machines. There were mechanically, pneumatically, or electromechanically operated. But now these machines have been embedded with computer system, which makes them more smarter, which makes them more programmable. So a computer numeric control is of two types, the additive and the subtractive. We have the additive manufacturing and the subtractive manufacturing. In the additive manufacturing, it entails the addition of filament materials to produce a finished workpiece, while subtractive entails the removal of silver from an existing workpiece to create a finished product. Now, the additive is more economical because there is less weight compared to the subtractive. In subtractive, more of material is wasted because it's being cut out. So now, ways a computer-based system ensures quality. A computer-based system can ensure quality with the following ways: simulations. With the aid of softwares, the performance of a product can be evaluated and can be approximated to what it will be, what the quality will be in reality. Now, also a computer-based technology can be used for inspection. After a product has been made, inspections can be carried out with the aid of computer vision. We could also, for technologies like computer vision, can also help in this inspection, where you check for defects in products. Then also a computer-based system with the aid of sensors can be used to detect parameters that are ideal or not. There are most parameters we set for an ideal product to be of standard quality. So with the aid of these sensors, we can ascertain whether our product is up to quality or not. Now, so we propose a recycled filament material, which is the polyethylene terephthalate PET. Now, these plastic waste are common in our environment. because these waste are non-biodegradable and thus can constitute nuisance in our environment. But the good news is that they can be recycled. According to the number 12 for the standard development goals, sustainable development goals, sorry. According to number 12, it says responsible consumption and production. Now, we should be able to have products that can be recycled or that are green, that can be able, we can recycle to make new products or are not harmful to our environment. Now, this plastic bottle is an example of a material that can be recycled and is littered everywhere in our environment. So we could recycle it with the aid of the 3D machine. We could make various products, like as you see there we have pens and foam pouch. Now, the major problem that prompted this proposal are the rate of plastic pollution and the quality of product and services. Plastic pollutions plastic pollution is almost is common, so it's common and is really constituting nuisance to the environment. The aim of this presentation is to propose a that is a cost-effective way of assuring quality through computer numeric control. And the objectives are to illustrate the economic and environmental impact of computer numeric control, illustrate how to build a low-cost 3D printer, illustrate how waste plastic can be recycled to filament material for 3D printing. And economic and environmental impact. Economically, it saves costs, it ensures quality, it increases productivity, it manages resources. While environmentally, it reduces weight, reduces pollution, fosters green products, fosters sustainable developmental goals. Now, the materials for this listed, the software, the Arduino IDE for coding the microcontroller, the SolidWorks for 3D, the repeater host for converting our 3D files to GMN code, and the slice 3R software. So, and these are the listed materials that we can use to achieve. Now, the workflow process is seen in the diagram, where you have you prepare a 3D object, a 3D model. The slice 3R converts it to STL file, then the repeater host converts it to G codes file to Arduino. Then the machine start printing. To recycle a machine, the process is
Apology, everyone. I believe we may have had a technical difficulty. We will resume the video once we have figured it out, and we will try to resume it from where we left off. Please give us a few minutes. While the issue is resolved, I would just like to remind our contestant, Mr. Sampson, that as soon as his presentation has finished, we would request him to please turn on his microphone and his camera, because he will have his question and answer session right after the presentation. All right, so the member who was sharing the presentation will be reconnecting shortly, and soon we will restart the presentation from where we left off. Apologies for the inconvenience, and thank you for your patience.
Now, the materials for this listed, the software, the Arduino IDE for coding the microcontroller, the SolidWorks for 3D, the repeater host for converting our 3D files to GMN code, and the slice 3R software. So, and these are the listed materials that we can use to achieve. Now, the workflow process is seen in the diagram. Here you have you prepare a 3D object, a 3D model. The slice 3R converts it to SCL file. Then the repeater host converts it to G codes file to Arduino. Then the machine start printing. To recycle a machine, the processes include collecting the plastic waste, drying the bottles, grinding and shredding the bottles to a particular particles smaller than 4 millimeters, preheating, extruding, spooling, and 3D printing. Now you could see this is the block diagram of all the interconnectivities, and this is the proposed model, the CAD model of the proposed 3D printer using wood. And you could see this is a 3D drawing which was later 3D printed. So here is the cost of everything. Is low compared to a conventional 3D printer, a ready-made conventional 3D printer. In conclusion, the breakthrough of this technology has drastically improved quality of product and services, unlike humans which are limited in senses, and a computerized system pose can pose variety of senses, and this is an advantage for fostering quality. Thank you.
We'll now proceed towards the question and answer session. So the participant is requested to please turn on their microphone and their camera.
Good day, everyone. I'm Samson here.
Okay, hi, hi Samson. I think we have the first judge, John.
Hi, Samson. Thank you for your presentation. I just love the idea of using recycled PET as a means of producing products. It just feels such the right thing to do. Can you give me some idea of what type of products you see this technology being used to produce?
All right. Normally, virgin PETs are used for plastic bottles, some like the beverage bottles from beverages and the rest. So we could also use them to produce maybe casing for home appliances, electrical home appliances. We could also, for modeling, there are some projects could be modeled with plastic. So we could also 3D print those using PET, also 3D prints for projects, science projects and other. And also, you can also recycle it to, there are varieties, plastic, anything plastic for the PET level, like for oils such as the automobile oils and the rest.
Excellent. So a wide variety.
Yeah, yes, sir. Yes.
Yeah.
Exactly.
Excellent. Thank you, Samson.
All right.
DTM Sarfraz.
Yes. Thank you, Samson, for your presentation. How did you get involved with this project?
All right. It came to me when I was thinking what could be a local way of making filament material for 3D printing, and also how can I get a 3D printer, or how can I make one? And while I was thinking about it, the thought of recycled plastic and pollution came to me. And making greener products. Pollution is something that is hectic. It's a nuisance, especially when you have plastics blocking drainages and waterways, especially the seas. So I felt like, what if these products, this plastic, they are being recycled and used to make other products that can also be recycled. So it's a closed loop process where you recycle. So I checked for research papers and the rest, and I saw it's actually possible. So Eureka, it came to me. That's how I got the idea.
Thank you. Appreciate it.
Okay. We move on to Peter Brewer.
Samson, thank you very much for the presentation. And like John, I really like the idea that you're using recycled materials. Did you actually produce the extrusion machine yourself for the filaments?
All right. I have a local plastic testing firm around, so I met them and we sorted it out and saw the possibilities. But there are actually there's actually a manual way to do it, and also you can also get help from them too. So that's how I went about it.
Oh, excellent. Yeah, using a local resource as well. Very good. Thank you.
Any questions from the audience, Suleiman?
No, sir. We currently do not have any questions for the contestants.
Thank you. Thank you, Samson.
All right, thank you.
Sorry, there was one more question from DTM Sarfraz.
All right.
Is that, has this question taken, DTM Sarfraz, or is this a new question?
No. Yeah, he answered the question that I had.
Okay, sure.
Thank you.
Okay.
Thank you.
Thank you.
All right.
Thank you, Samson.
All right. Thank you.
Thank you very much, everyone, and the best of luck to the participant. Moving on, our final contestant this afternoon is Mr. Brian Atobra, hailing from the University of Energy and Natural Resources in Ghana. Mr. Brian will give his presentation on his topic of nuclear energy.
My name is Atobra Efri Ibrahim from the University of Energy and Natural Resources, Sunyani, Ghana, in the Middle East and Africa region. The title of my presentation is Nuclear Energy. So first, we are going to understand and define nuclear energy. We are going to understand the science behind nuclear energy. And then we move on to the ways of generating nuclear energy. That is nuclear fission reactor. Then we move on to the advantages of nuclear energy, and the disadvantages of nuclear energy, then the future of nuclear energy. So someone would ask, why did I choose this topic? This topic was chosen because energy consumption is increasing yearly. As a student of engineering, it's best we understand how massive the energy from nuclear energy can be. And then we can use that one to reduce carbon emissions. As fossil fuels is projected that 2070, they might be depleted. So let's move on straight to what nuclear energy is. Nuclear energy is the energy stored in the nucleus of an atom. Nuclear energy is released during nuclear fission or fusion. That is, nuclear fusion is the coming together of lighter nuclei to form a heavier one. And then we have nuclear fission, that is the breakdown of nucleuses, of heavier ones to form lower nucleus. And this one happens with the release of energy in the form of heat, which the heat is tapped to produce energy. So the nucleus is the core of the atom, and then has most of its mass, as I've gotten into the slides, a smaller picture of the nucleus, so that you can get to understand how the nucleus is. So it has most of the mass of the atom, and then from Einstein's famous equation, we can get to understand that E is equal to mc squared, where E is equal to energy, m is the mass of the product, and then c is the speed of light. So here, from E is equal to mc squared, you get to understand that the speed of light is huge, and then it is also squared. So a smaller mass can produce vast amounts of energy for our use. And mostly, the energy preferred in nuclear reactors or nuclear energy production is uranium and then plutonium. So we get to understand that before we can move on to the nuclear energy production, we get to understand that United States, the countries that use nuclear energy and then they are still moving on correctly. United States is one of the stable countries in the world. They have 19% of their electricity coming from nuclear energy. France has 70% of their energy coming from nuclear energy. And then Russia has 19% of their energy coming from nuclear energy. And South Korea has 25% of their electricity coming from nuclear energy. And this is according to the US Energy Information. So we move on to the major part of the nuclear power plant. The nuclear power plant has moderator, it has a coolant, it has a coolant. A coolant is what is used to cool the system down and then prevent it from overheating. It has a moderator. Moderator also slows down the neutrons produced in the process. And then we have the fuel use, as I said earlier, we have uranium and then plutonium. The specific uranium used, the isotope used is uranium 235. And then we have a containment, a breach, a form of deodorant that prevents the radiations from getting into the environment. And that is called a containment. I'll show you a picture of that one soon. And then we have the steam pipes, which are made of steel. They prevent the heat from getting into the environment, and then they control it in the direction to the turbines to produce energy. So we move on to the ways of generating nuclear power. That is from the nuclear fission reactor. The nuclear fission reactor is a series of machines that control nuclear energy production in a controlled way to produce energy in an output of electricity. So this energy is controls the energy in a particular way that they can produce energy to us in the form of electricity. And then they have the steam pipes and other things in place to control the system. You have the picture of uranium ore here. There's a yellow part the guy has dipped the cap into. And then it's a radioactive element, so you have to protect yourself before you get closer to it. Then they are stored as pellets of uranium oxide. That is the picture the guy has one in his hands. When they are stored as pellets, they are safe to hold and then use. So we move on to ways of generating nuclear power. We move on to ways of generating nuclear power. That is, first, the nuclear reactor has a lot of types of nuclear power plants. And then some of them are pressurized water nuclear reactor, that is the PWR, that's boiling water reactor, lots of them in place. But we are going to just understand how nuclear energy is being produced, the general way of nuclear energy being produced. So we have a data here which presents you some countries and kind of nuclear reactor they use in production of their electricity. But since we're not going to dive much into just the production of it, we are going to understand the general production of nuclear energy and how it's being done. So let's move on. Then this is the concept of production of nuclear energy. That is how nuclear energy is being produced. The data here is provided by Sidney Baelish in 2015, which tells you that the containment, as I said, is a meter thick brick. That is the yellow part of it over there. And then we have the uranium, where the uranium 4 is being kept. That is the green part of the containment. That part, the uranium is placed over there, bombarded with protons or nuclei to produce energy. When they get bombarded, they release nuclear fission products. This product then produces energy. And then when they release nuclear fission products and then energy, the nuclear fission product also bombards other nucleuses to produce energy in the process. And then this is called a chain reaction. It is continuous. So the heat produced in the process is transferred to water, heats up the water at high pressures and at high temperatures, which when, according to thermodynamics, when something is heated, the pressure around it is also increased. So when this happens, the water is moved at high pressure to the turbines and then turns them at high speeds to the generator to produce electricity. This is the basic understanding of the nuclear energy. The water then is then